everyone. I'm Parul from Team Asclepians, and our project topic is pre-populated patient intake form. As part of Sprint 3, there were two tasks that we had planned. One was building the screen prototypes, and another one was preparing the detailed solution architecture. While working on the wireframes, we decided to take a design life cycle approach, and we conducted need finding exercises through market research and looking at various patient intake forms that are available online for different service providers, and looking at that information and identifying the different fields that are used in the intake forms, we came up with the workflow and the common fields that we want to add to our app. While designing the wireframes, we considered few important design principles such as discoverability, ease, comfort, simplicity, so that it's easy interface for a patient use, as well as also we looked at some of the other principles like structure by providing different grid and tabular format, as you can see on the screen as well. Also consider that we'll be adding different input data validation, because in our app, user will be able to edit the details which are there on the screen. So we would want to add constraint and add some tolerance limit, whereas we will have some hints provided to the users when it comes to typing in the medication name or a disease name or something like that. So looking at the patient's view here, the first thing which will come on the screen when the patient logs in would be the consent form. Once user clicks on agree here, he'll be taken to the patient intake form view, where you can see there's personal information, then there's medical history, and then there'll be medication list, allergies, health habits, family medical history, and also a section whereas they can type in the details related to their current visit, like what concerns do they have, what exactly do they want meet the doctor for. On the provider side, once patient submits the changes, since patient can edit the fields and provide an updated information, so then that information, once patient submits, will be saved into our app database. Before synchronizing this update to the FHIR server database, we would want provider to review the changes and be able to approve and reject. So on the screen, you can see as provider logs in, he'll be able to see the list of patients who have submitted some changes and the updated details. By selecting a particular patient, provider will be able to see what information they have updated, use the whole bar to look at all the information there, and be able to approve and reject changes. On click of approval, it will be synced to the FHIR server.
On this slide, we can see an architecture diagram of the system. At a high level, 3 tiers make up the entire system. The presentation tier, where lives our client-side logic in the form of React components. The business tier, where we expose the various APIs that the client-side logic interacts with via HTTP. And the persistence tier, where we save patient intake forms data in approval status. The client-side logic will never read and write data directly into the provider's FHIR server. Instead, it interacts with the APIs comprising the business tier. For a patient filling out intake forms, these APIs fetch data from the provider's FHIR server and save it down to the patient intake forms database. For a care provider reviewing a patient's intake forms data, these APIs retrieve data from the patient's intake forms database and eventually push it over to the provider's FHIR server. The business tier shall contain the following components: a patient history CRUD APIs containing past medical history, past surgical history, social history, family history, home meds, and signs and symptoms. Patient and patient allergies CRUD APIs containing drug allergies and patient intrinsic attributes like name, address, contact information, birth date, etc. Another component is the appointment CRUD APIs. These are things like consultation reason and additional information. Also, we have consent CRUD APIs. These are components recording various consents that the patient has to provide. Finally, we have the Forms Review CRUD APIs, allowing the provider to review and approve the forms provided by the patient. The components on the presentation tier mimic those of the business tier and are React components instead of web services.
I will now go over the front-facing presentation layer of our application. So the goal is to create a user-friendly, highly interactive app with a rich front end and a modern feel. To accomplish this, our web app will be based on the basic building blocks of JavaScript, HTML, and CSS. We have chosen to use the React open-source JavaScript user interface library. React is the current standard in web app development and makes it easy to quickly create highly interactive user interfaces in a single-page web application. It abstracts away having to manually update the HTML displayed on the browser's document object model and allows the programmer to focus on writing reusable UI components through a variety of programming paradigms, including functional and object-oriented. We will also be using Nginx as a web server to help manage and balance the load of requests from the client application to the Python backend. When building our app, we will be following current best practices in web development. That includes using ESLint and Prettier for our JavaScript and React development. ESLint is a static code analysis tool that can help identify problematic code, such as using the wrong equality operator in JavaScript, and it can enforce code style rules. Prettier is a code formatter, which is oftentimes used in accordance with ESLint's style rules to format JavaScript code as you write it. Using these two development tools will help us write a more robust, stylistically uniform codebase. For front-end testing, we'll be using Jest, which provides easy hooks to test both the logic and rendering of React components. And finally, we'll be using Webpack and Babel. Babel is a JavaScript transcompiler or polyfiller, which means it can process modern JavaScript and make it back compatible with older browser environments. For example, though in the JavaScript spec since ES6, arrow functions may not be fully supported in every environment we will expect our application to run. Babel allows us to use arrow functions while developing, and it will transcompile our code into an older syntax when we distribute our application. Webpack is a module bundler and handles processing our project's code, dependencies, and assets. Webpack ultimately generates a single index.html file, which is the entry point for our single-page application. Finally, we'll be using a UI styling framework to help us achieve a modern look and feel for our application. We'll be using either Material UI or Semantic UI, both of which include styled components such as forms, text fields, checkboxes, and dropdowns with enhanced JavaScript event handlers and will help us reduce the amount of time spent writing custom CSS. Since the front end of our app will consist mostly of different types of form inputs, using a framework like Material or Semantic will help us provide the best user experience.
In this slide, we review our technology stack for the business layer. We've decided to use Python 3.x because most of the team members are familiar with it, as it's used in many of the classes that we've taken, and it's widely used in the industry. We're also going to be using Flask as a web framework to write our service APIs. Flask is very minimalistic and easy to pick up. Finally, we're going to be using the Fire Client Python library in order to interact with the Fire server. For the persistence layer, we revised our choice to using MongoDB instead of SQLite. MongoDB is a document database that allows for easy storage and retrieval of JSON documents. This serves well our use case of exchanging JSON Fire messages. Moreover, there are many open source packages and tools that ease the integration of MongoDB into our overall tech stack. Here, I have listed two of these packages.
The deployment pipeline will utilize CircleCI, Docker, and the Python unit test framework. CircleCI will be used to execute the build process. It uses configurations saved as part of the codebase. Docker will then deliver the application in a container. The following steps will be performed by CircleCI. The Python virtual environment will be initialized. The Python unit test framework will perform necessary unit tests and check for success. The Docker image will be built. And finally, the application will be deployed to the necessary server.
We come now to the Sprint 3 Gantt chart update. As you have learned, we had two objectives for this sprint. The first was to develop screen prototypes for our app, and the second was to flesh out the solution architecture. We are fortunate to have a good team with diverse skills and interests. This enabled us to accomplish these objectives with solid contributions from every member of the team. Our wireframes are in place, and we have a comprehensive architectural diagram. In addition, we have settled on what is likely our final technology stack, and our developers have already begun to set up the working environment. This gives us a head start on sprint number 4, where we plan to begin building our code base and our deployment infrastructure. We are the Asclepians: Daniel Arch, Anthony Bosshart, Ed Hayes, Matthew Kalita, Parul Kosla, and Marouane Marzuki. We remain grateful to our mentor, Ellie Shivers, for all she does on this project and what she brings to IHI. Thank you very much.